Alright, welcome back everybody. In this video we're going to look at how we interpret particulate motion when we're looking at a graph. And we're going to look at a couple of examples. The first example here, the graph below shows the velocity of a particle moving along the x-axis. We're going to answer the questions that follow by using the graph, and we're going to explain our reasoning in each of these. First of all, it's key anytime I'm looking at a graph and using it for interpretation that I understand what the graph represents. This graph represents the velocity. Okay, so this is my velocity function. And all my answers to these questions are going to be based off of the fact that this is the velocity function. So let's go ahead and look at the first question. When is the particle moving forward? And so we've got this particle that's moving along the x-axis. When we talk about moving forward, that means that it's moving to the right on the x-axis instead of the left. So what happens when the particle is moving forward is that it has a positive velocity. And so we're looking for everywhere on this graph where the velocity is positive, which is above the horizontal axis. And so we've got the time interval from 0 to 2.5, and the time interval from 4 to 9, particles moving forward. And we can explain our reasoning by saying velocity is positive on these time intervals. Alright, next I look at question number 2. When is the particle moving backwards? Well, that's the exact opposite situation. We're looking at where the velocity is negative. So we identify and look for all the places where the velocity graph is below the horizontal axis. And that happens from 2.5 to 4, and from 9 to 10. And my reasoning, velocity is negative. Alright, next, question number 3. When is speed the greatest? Okay, speed is the absolute value of velocity. And so if you could imagine a graph of the speed function, and that would just take all the velocity that's below the axis, move it above the axis, and if we're looking for the place where the speed is the greatest, it's going to be the highest point on this speed graph, which happens right here at time 6. And the way I'm going to describe that here in my answer is, this is where the velocity graph is furthest away from the horizontal axis. Indicating maximum absolute value, and speed is absolute value of velocity. Alright, so there's question 3. Question 4. When is the acceleration positive? When is the acceleration positive? I'm going to erase my marks that I made in part C. When is the acceleration positive? Well, if you think about the relationship between acceleration and velocity, acceleration is the derivative of velocity. And so the acceleration is going to be represented by the slope of the velocity graph. So since we have a graph of velocity, the acceleration is the slope of this graph. So we're looking for places where the slope is positive in order to identify where the acceleration is positive. So I look back at the graph. The slope is positive, looks like from time 3 to 6. And that's the only time when we have a positive slope. So that's going to be our answer for this. It's going to be the interval from 3 to 6. And we will say slope is positive there. And since acceleration is the derivative of velocity, it is represented by the slope of this graph. Alright. Question number 5, when is the acceleration negative? So we'll use the same reasoning that we did in question number 4, except now we're looking for where the slope is negative. So we'll go ahead and look at the graph. The slope is negative from time 2 to 3. There's a bunch of intervals where the slope is negative here. 2 to 3. And from 6 to 7. And from 8 to 10. And same reasoning, only with negative instead of positive. Slope is negative there. Comma. And then since acceleration is the derivative of velocity, it is represented by the slope of this graph. I think we've got one more question on this one. Question 6. We've got one more question. When is the particle changing direction? Now we talked yesterday, or whenever it was, in the particulate motion algebraic standpoint, that the particle changes direction when the velocity changes from positive to negative. So whenever the graph crosses through the horizontal axis, those are going to be the times when the particle changes directions based off of this velocity graph. So we've got time 2.5, 4, and 9. T equals 2.5, 4, and 9. These time values are when velocity changes sign. From positive to negative, or negative to positive, indicating a change in direction. Alright, that's it for this example, and we'll close this video up here and look at example 2 in the next video. See you guys next time.